This is the Amp Hour Podcast, recorded June 9th, 2014. Episode 202, with guest Brandon Harris, Impish, Internet, Iamatology.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And I'm Brandon Harris from Electric Imp.
Hey, Brandon. Thanks for joining us.
Thanks for having me, guys.
Yeah, we're super excited to talk to you because basically we're Wi-Fi idiots, to put it lightly.
Wi-Fi is that thing that was developed in Australia, right?
Yeah, right.
That's all I know. Right.
If someone walked up to me and they're like, "Hey, I need you to really, get this thing onto the internet and do it quickly," I'd probably run away.
No, you just buy one of the
That'd be a good choice.
oodles of off-the-shelf modules. Come on, be proactive, Chris.
Yeah, no. But the thing that's interesting to me is that, there's a lot of companies out there doing modules, the software side as well. So it seems like Electric Imp's really doing a lot of that and making it easier to get hooked up and started and everything else.
For a dummy like me to get onto the internet, I can do the hardware side of things, but and I can choose any module. I don't care about the hardware. I care how easy is it on the software side for an idiot like me to have my microcontroller spitting out data to the web or wherever I need it to go.
Yeah, so that's kind of exactly what we were founded to solve. Our founder Hugo was doing your standard hobbyist project. He wanted a set of lights in his bathroom to go green when the Apple stock price was up and red when the Apple stock price was down, right? And he did what sort of your average hobbyist does, and went and bought himself an Arduino and a Wi-Fi shield and got it all started up, and he was spending nights and weekends getting it going and figured out, a Yahoo feed where he could pull down XML, and he's parsing the XML on his 8-bit microcontroller, which is something, a lot of people have had to do before. And it's something that's a really awful experience.
Yeah, I know. You could waste weeks on that. That's the thing. That's the demoralizing thing. Like, as a developer, you might go, I don't have time to do that. Geez, I can't spend a couple of weeks dicking around with, a module and passing XML and getting data out and all that sort of jazz.
Right.
It's fine if you've done it before and you're sort of, your mind's in place to do that sort of thing, and you can probably do it quite fast. But, if it's your first shot at it, you're just going to be bumbling around.
And the problem is, even then, it's like, you do that for one feed, and you get it parsing XML, and then, they drop XML support, and now you need to do JSON, right? And you throw the whole lot out the window, and you just decide it's not worth it.
Yep.
So, while we do make our own hardware as well as partner with other hardware makers, a lot of what Electric Imp is really about is the service. It's really, I like to think of it more as an internet module than as a Wi-Fi module. Because getting on Wi-Fi isn't that hard. There are lots of modules out there. You can connect to Wi-Fi and you say, okay, great. Now what?
That's it.
Right? It's like, are you going to be parsing, JSON on your microcontroller? How are you going to update your device? Because it's going to have bugs.
What
it's
is
connected
JSON?
to the internet. JSON?
Mm-hmm. Yeah.
So JSON is a JavaScript serializable object notation. I'm almost certainly completely wrong on that.
And we've learned something new, I think.
Well, I knew what JSON was, but yeah.
JSON is just a structured data format. So it's a way, like XML, it's a way of passing data between different devices. So it's nestable, and it's phenomenally complex but extremely powerful. And actually, once you have a good JSON parser, great to use.
Right.
It aligns with like lots of the program structures that we think of when we think about higher level sort of object oriented languages, of being able to nest things and having keys and values and things like that. So I should also mention that I am a hardware engineer.
Yes.
and moonlights as a
one of us.
He just happens to know more than the average bear, it seems like.
Yeah, but you pick up a lot when you surround yourself with smart internet guys. So
Right.
Yes, blah blah blah, object oriented, yada yada
yada. So our whole idea is that we basically handle everything from, basically you get your device has a URL that only you know, and then you can actually use that URL to interface with it, right? So you can have a device that literally serves up its own web page. You click a button on the web page, and that sends a message down to the device and turns on an LED.
Got it. Is this something you can run on your own server, or do you get the URL on your website? I say this because I don't want to jinx you or anything, but hey, what if you guys go out of business or something, or your website's flaky or something like that? How does that all work?
I mean, that's a question we get a lot, right? And one of the things you have to think about in this day and age, right, as things become more and more interconnected, it becomes more important for the services. And as people start using more services, it puts them at greater risk that one of those services goes away.
Sure.
But so right now we only offer it to run through our servers, and we have good funding and we expect to be around for a long time.
Yep. Are you guys running your own servers, or do you shop it out to Amazon or something like that?
Yeah, we shop everything out, right?
Right, of course.
We don't want to. We're not server maintenance people
Right.
and things like that.
Yeah,
Why that fail after all the hard work on the software?
Right, and it actually, I mean, it actually lines up kind of well that we sort of have positioned ourselves as sort of the AWS of IoT connectivity. Right,
Whoa.
where
there are more acronyms in there. You can
We're going to have to take a second here, Brandon. We need to take a moment of silence for the,
I know. This is what happens when you get prepped by marketing guys.
If you say IoT 14 times, you get a bonus.
So funny story. We actually, one of my colleagues, Yanir, literally built an IoT device, as in IOTEA, which is a power sensor that hooks up to the electric kettle in our kitchen, and we have a sign up in the office that goes red when the water is ready and hot, because the kitchen is far enough away you can't hear the ding.
Nice.
So that was the first IoT device. And,
nice.
Goodness.
But puns aside, yeah. So we like to think of ourselves as the Amazon Web Services of the Internet of Things. That's
guaranteed to get investors moist at
well, so the idea is that nothing Amazon does is things that you couldn't do, right?
Oh,
right.
No, but they do it on such a scale that you'd be stupid to even try.
Right. So that's exactly what we do. We've shipped coming up on 500,000 connected internet modules.
Nice.
Right. So we know how to maintain links. We know how to navigate firewalls. We know how to get on. One of the things is just routers in homes have bugs in them, right?
Yeah.
Things that are specifically forbidden in the spec for Wi-Fi, some routers just implement, right? Zero length password. Sure, I'll accept that. So things like that we get to test, and it's the sort of thing where it's somewhat unfeasible for an individual smaller company to try and collect all that data. But because we've been shipping, and because we're tested on so many different networks in, I've forgotten how many countries, 30 or 40 countries around the world, we get this tremendous exposure, and we're able to aggregate all that information and do it exactly like you said, on a scale that we think anybody else trying to do is foolish to not leverage that learning we've done.
Can you see? So you said 500,000 devices that are out there right now. Can you see so those are driving regular traffic back to your servers as well? You can see all that analytic information, when someone turns a light bulb on kind of thing, or how does that all work? And I don't mean like in a creepy way either. I mean like an aggregate, like just like how many devices are active and all that kind of stuff.
Yeah, so I mean, we have sort of active device counts and things like that.
Yeah.
A lot of the devices are not continuously connected because one of our core areas of expertise is power management. And if you want to do something on batteries with Wi-Fi, typically what that means is turning off Wi-Fi and going to a sleep state when you're not doing anything. So there's a Budweiser hockey light that's sold in Canada. And basically wakes up for, you set whatever your favorite team.
Yep.
And then it only turns on during the game and basically notifies you when your favorite team scores a goal.
Right.
And because they run off of batteries, they don't want Wi-Fi on all the time. So, we do see when the more popular hockey teams have a game, we get a little blip on our server of connections, which is pretty funny.
I'm just impressed that Budweiser can sell anything in Canada, to be honest.
Well, so yeah, they sold like hotcakes. They
Really?
announced it during the Super Bowl last year. It was actually the first product to ship on the first commercially available product on our platform. And it's Canadian hockey fans, right? And it sort of points out that like we have this notion of like, internet connected devices as being a very nerdy thing.
Yeah, right.
And that's really because of our imagination is bad, right?
Right.
Somebody else imagined a different use for it and made something that's really desirable and isn't nerdy in any way.
And your average Joe looking at that thing or buying that probably wouldn't even know or care it connects to the internet or has heard of the Internet of Things terms or anything like that.
Absolutely.
Yeah. So would you say that here's the $1 million question. Probably should have left it to the end, but we'll throw it in now. Would you say that an Internet of Things company is like you're probably pushing the brown stuff up the hill with a pointy stick if you're trying to make a real big business out of just selling hardware? Is the software everything? Like the hardware is almost pointless getting into. It's the software side of things that is ultimately going to make you successful and make you money.
Yeah, I mean, right now where we are, software is king. I mean, that's something that you don't have to look any further than Arduino, right? It's not like an Arduino processor is better.
Hardware is nothing. The hardware is just the same hardware that's been around for 30 years. It's no big deal, right?
Yeah, it's all become so commoditized.
Yep.
And so really, you're right. It's about software and about creating compelling user experiences. So one of our...
Another buzzword. Jeez, our people's bingo sheets are going to be full after today's episode.
Yeah, so
I've heard that term so many times from people who run startups. It's need a compelling user experience or something. Like, is there some playbook?
Well, you hear it a lot when you're living in Silicon Valley.
Yeah.
Eventually, people shout things at you long enough, you start repeating them. No, so I mean, it's the point is that. One of the things, like you look at some of the early successful internet connected devices, like the Nest, right? The Nest was, the internet connectivity was only part of the story, right? It was about a beautiful design and, sort of selling this as a premium product and a whole package. And that's where people are, I think there's a lot of interest in that these days, where it's like, people want to feel good about their devices. They want to have some sort of, positive relationship with them, much in the same way that, that's happened with the phones. Like people feel like, if they go to work without their phone, they feel,
naked,
often feel lost.
Yeah.
And I think that's going to start happening with more and more things.
Interesting.
I came to the office this morning without my watch. Oh my goodness. I cannot go out without wearing a watch. It bugs me. I feel naked. Yep.
Was it a pocket
Yep.
watch because
So
you're like an old person?
Right.
Who has watches anymore?
Watch,
This is sorry, couple guys. I'm just I still don't
See,
understand
I
the
don't
watch
carry
thing.
my phone. Well, like if I go out without my phone, oh, whoop-de-doo,
Yeah.
But my watch, no way.
Hmm.
No, it's just got something I've got to have on my wrist,
And I think that does point to what a lot of people are trying to do with, like you said, with the experience, Brandon. Like the people are trying to craft these have to have kind of things, and of course, have to have means you have connection and everything else. So it kind of how many of the companies that are using Electric Imp and stuff like that? I mean, are they outside of the realm of being able to hire people that could do this kind of stuff, or is it just more of a business decision where they say, well, we want to prototype quick and then we want to be able to also push that to production, or is it something else entirely?
So it's some of both. For some things, smaller companies, we have companies that are shipping in the few thousands, and for them, they just simply couldn't justify the cost of doing all the development themselves. I mean, just getting, a product FCC certified can cost 10 grand or more, right? If you're only making 5,000 of something, you can't be wasting your time with that.
Yeah.
But it's about the fact that they also don't have the expertise, right? One of them is a toy maker. They don't know about Wi-Fi. They don't know about networking, right? They just knew that they wanted their toys to talk, and so that's really what we were able to bring to the table for them. For some of the larger customers, where it's maybe more, they can amortize the development cost across more products. There a lot of it is time to market. You look at Quirky and they're able to bring internet connected devices using our platform to market incredibly quickly.
Yeah.
And for them that's the real value. So that yes, they could develop some of those resources in-house, but again, they're able to leverage, we have other large customers, and every customer gets the bits as the platform grows. So we have a really positive networking effect right now that
Got it.
Really helps all of our customers every time the platform grows.
Let's dig into a little bit. Tell us about tell us about the hardware, and then what it would take to get dummies like Dave or I up and running, hooking up our DMMs to Wi-Fi, or hooking up bench buddies to Wi-Fi, that kind of thing. What would it really take, and how long would it take?
Hang on. I just want to say how amazing it is when, I've been working in the electronics industry for more than 20 years as a design engineer, and here I am being called a dummy.
I call you a dummy every single week, Dave.
I know. But this is how, the landscape has changed. This is how the landscape's changed. I just find it remarkable. Sorry, go on.
Yeah, so I mean, fundamentally, at its core, just to give you a little idea about what the Imp hardware looks like, it's a Broadcom Wi-Fi chip. This is the same Wi-Fi chip that's used in iPhones and other kinds of smartphones, plus a STM32 Cortex M3 ARM microcontroller.
Do you need that 32-bit ARM power? Or is there some other reason you chose it?
So to some extent, there certainly are people that have done it with, we have a pretty powerful microcontroller. If you're doing TCP/IP and holding lots of buffers, and actually one of the other big things is we do all of the every single packet we send is encrypted. So when you start getting into that, that's pretty serious. CPU.
Yeah, can't quite run it on an 8-bit micro, can you? You probably could, but it'd be dog slow.
Yeah. Well, and the other big thing is it's these things always, it's never like, well, you get a really good processor and no memory, or lots of memory and a really bad processor, right? Some of it is, we needed the more memory, so you get a faster processor.
Got it. Yeah.
And one of the big things that's different from a hardware perspective, that's different between an Imp module and most Wi-Fi modules is many Wi-Fi modules are just intended to be basically a Wi-Fi modem. where you just talk serial commands to it. And so it doesn't have to have a lot of onboard memory or processing or anything like that. We actually let you write hosted applications that run entirely within the Imp on that ARM microcontroller. And because we have a more powerful microcontroller, we're able to let you do that in an interpreted language.
Oh, okay. What, you've got your own language?
So it's Squirrel. A squirrel. Yeah, squirrel.
Do you do that around the office a lot? The thing from Up, that movie?
Yeah, it was. So we actually started back in the very early days, we were using a language called Lua, which is used in gaming engines
and Keithley DMMs or Keithley Smooths, actually.
Yeah, so it's got kind of these like strange applications, but what's great about both Lua and Squirrel is they both are designed to be relatively efficient because they're designed for writing plugins for games, and so they have to have relatively high performance. So we're actually able to compile them into something reasonably efficient for a microcontroller.
Interesting. Right.
But honestly, the reason we switched from Lua to Squirrel was Lua stores every single variable as a double.
Oh, okay.
And has no arrays.
Yep.
So an array is really just a table with a numerical index, which means
that's
you want to put bytes into an array, and you're taking 8 bytes per entry.
Yeah. Ouch.
Yeah, it's a pretty big overhead. Squirrel doesn't have that. So it's an uncommon language. It's actually syntactically very similar to JavaScript, which actually fits our platform really well. It's it's odd because as a hardware engineer, I'm used to coming at these. I think of this as coming at it from a hardware solution, but in fact, a lot of what we're seeing is this is really a way of the software and the web guys invading the hardware space. So we have guys who are used to writing web pages who are all of a sudden writing embedded device code,
right?
Which is terrifying to me.
Yeah. So is it cool with like 64 megs of memory to flip this LED on, or is it like should I go higher? Is it like 4 gigs?
Yeah,
only like 4 gigs or so. Sorry, software folks.
Yeah, it's funny. Like I feel like every day I work here, I make myself less needed.
Right.
I mean, ultimately that's kind of the goal of any good hardware engineer, right? Is like you never want the software guys coming to you, right? It's like that means you did something wrong.
Also, from a business perspective, teach a man to fish and you lose a wonderful business opportunity.
Yeah. So the hardware is pretty straightforward. We have a nice beefy processor on there where it means that you're writing an interpreted language. One of the great advantages of that is that basically we have a lower OS layer that handles all of the connectivity, the encryption, everything else. And basically it's, our goal is to build a platform that's so stable that no matter what a user does, short of, blowing the thing up physically, they can't break it with software, right? So this is, again, that's the other goal of the hardware engineer, is to over-engineer things such that no software engineer can ever break it.
Sure. Somewhere out there's a software engineer saying, "Challenge accepted."
Yeah, the number of engineering hours I've spent, trying to make sure that the software guys don't break my stuff is substantial.
At what point did you switching languages like this is a huge deal, not only to you but to the user and the product. At what point did you decide to do that, and does it leave everyone previously who came up to speed using that language now, you've dumped it, go to something else? How does all that happen?
We actually switched from Lua to Squirrel 1 week before we launched the product.
There you go. Okay,
so thanfully, yeah. No,
right.
That sounds like a great decision overall.
So literally, we had,
was
we were ready to launch.
Gamble though?
What's that?
I mean, was that a huge gamble? I mean, just a week before launching?
Yes.
Switch to another.
It was a huge gamble.
Was it something that the other one was just so bad you thought, if we don't do it, we're just going to fail?
Yeah,
we're just going to.
It really was.
Oh, okay.
Right. So what it came down to, and this is one of those things that, like, where it's just like you just don't learn except by doing. So we we had we launched we announced the product 1 week before Maker Faire 2012. And so Maker Faire was going to be the first public exposition of the technology. And so we were building all kinds of demos to sort of show what kinds of devices could be connected. And so one of the devices I built was a 16 by 16 RGB LED sort of display, just made out of the strips of LEDs you can buy off of Adafruit or
the addressable
AliExpress,
ones,
etc. Yeah. And literally that's where we found out this nice feature of Lua that arrays are so inefficient. Was I was trying to animate the display and make it do things, and I kept running out of memory. And we have 128K of memory, and about half of that was at the time was used by the operating system, and all of a sudden I'm spinning up 60K of memory to store a few kilobytes of data, and that was a big aha moment for us, where we just said that's it. That's a deal breaker. We can't live with that level of inefficiency. And that was on a Friday, and Hugo, our CEO, and our embedded team just spent the weekend researching stuff, and found Squirrel, which was actually I believe originally written sort of as a alternative to Lua, because of some of the frustrations with Lua and some of the weird syntax with Lua.
Yeah.
And it was a tremendous gamble. I'm quite frankly just absolutely amazed that it worked. But it was one of those things that that once there are users on the platform, you'll never be able to switch, and you're going to be living with that bad decision from forever. And I think ultimately we would have delayed the product rather than ship it with the wrong choice of language.
Yeah, well, I mean, it seems like it's been working out since, right? I mean, so what is the reception then when you go to, when people start up, then is it like, what is this? Or is it just like, oh, this is what I have to do in order to get, what'd you call it? AWS for IoT.
Yeah. So it's actually, it's some of both, right? Some people come at it, and especially people who are thinking of this more as a web page, right? And they can do sort of, JavaScripty like things. And so if they're coming from the web side, they absolutely love it, right? They don't want to have to be writing C, and doing while one loops. Is like they're used to being event driven and callbacks and things like that, which is very hard to do on your average microcontroller. And that's what Squirrel is all about. And so for the people who have the hardest time with it are the really old school, I've been programming, microcontrollers since the 70s.
The peek and poke guys, huh?
Yeah. And so that's kind of one of the hardest things, I don't want to, dump on that crowd at all, because, I think they do great work.
Go on.
But
nah, it's all right.
But one of the great advantages for us is, a lot of the companies that are really on the cutting edge are, more flexible. The engineers are, from a newer background, and they started learning, their first language wasn't C or assembly. It was something higher language, and they're writing in, Python or Ruby or JavaScript as one of their main languages. And so for those guys, it makes total sense, right? Once they get over it's named Squirrel, but it's basically JavaScript.
Right. Yep.
Then it's a really excellent tool for them.
Well, I've found that those people brought up on those sort of languages, they can switch really easy, from JavaScript to Ruby to Python or whatever it happens to be. They just seem to pick it up really easy.
Yeah, I think that's, one of the things that has happened, and especially it's also just a requirement, right? I mean, if you started programming way back when, C was the language for so long that you just and you had so few resources, you had to really understand the the physical level. And now your average programmer doesn't actually understand what's being executed or how it affects the computer, but they know how to get things done, right? They know how to read API documents.
Yeah, that's right. Yeah.
So what's that memory made out of again? It's like some kind of semi conductor.
Yeah.
And that's why they often make guys like, hardware guys like us look like fools these days, because they're so good at getting the job done, whereas we're dicking around with hardware and in our old mindset, that.
I think that also means that Brandon's always going to have a job if he wants one too, right? Because that's what that's what happens. You abstract out these interfaces, and then when there actually is a problem, then that becomes all the harder to actually go and dig down and solve it. You just hope that, like Brandon's saying, you kind of work yourself out of the system by fixing all of the hardware bugs.
Right.
Yeah. I mean, I think it's actually great. And even as a hardware engineer, right, I'm also aware that I have to be, that in this day and age, it's like that's just sort of what's required, where you're not going to be sitting down and working on one project for 3 years. In the last 2 years here at Electric Imp, I've worked on 20 or 30 different designs.
That's awesome.
Yep.
Right. And it's like, I mean, there was a point in time back in the beginning, I was fabbing out a board every 2 weeks.
Nice.
And I got into the cycle where I could, I got a pipeline going where it was basically I could do a design in a week, and then I would get back my previous design, validate it in a week, and then move on. And a lot of that is because the Electric Imp hardware is so powerful and well tested, and the software for it is so easy. I was writing whole new device drivers in a few hours, which is just kind of unheard of, and it makes the hardware so much more fun, because rather than saying like, oh well, what can I find software for, I say, wow, I don't care, what can I buy on SparkFun, what is cheap on DigiKey, and I just throw it down, and it's like, if the data sheet's reasonable, we can get simple device drivers up and going in a few lines of code and a couple afternoons of work.
So when you say like device drivers, you mean like having like an ADC or some kind of external device where you're actually peeking, or you're throwing stuff at the registers, reading back from the registers, just simple stuff like that. But then you get to write. Then you have like a web page where you go and you just access that kind of thing. Is that what you mean?
Yeah. So I mean, like a good example was we use accelerometers in a couple designs, and just something as simple as figuring out how to do a free fall detection. So I had a little design. I had an accelerometer and some 2 AA batteries on it and an Imp module, and it would wake up when you tossed it in the air. It would wake up, connect to the internet, and go back to sleep before you caught it again.
Oh, that's fun.
Which is pretty fun. I mean, and it was silly, but it's like, well, all right, how hard is it to figure out how to do a free fall detection? And because there's, the I2C and everything else is all built into the operating system, you're not faffing about with, read this register, then set this register, then read this register and set this register. And, power management is, literally going from offline in deep sleep to online connected to the internet, sending data, and back to sleep as a few lines of code.
Right.
So
how long does it physically take to go from sleep to fully connect, to sending something out to the internet to shutting back down? How quickly can it actually do that?
So interestingly enough, the slowest thing in the entire path is the local DHCP server.
Right.
Really? And so, like typically...
Well, yeah, it's a freaking server. I don't know. It's got to do server stuff, right?
Yeah, right.
It's got to... Okay.
I don't know what it is. So there's a lot of steps that go into actually connecting and things like that. Here in our office, we've got real fast internet. We have a nice beefy server, things like that. We can actually connect, send data, and get back to sleep in a little under a second. Sometimes, just over, but about a second.
Well, yes. See, to me, that's quite long. That's quite lengthy.
Yeah.
But hey, if you're running a DHCP server, then that is what it has to be, right?
Right. It's there's a lot of things going on there, right? You've got a lot
of course, yeah.
There's a lot of steps, and getting an IP address and things like that can be, just getting on the network and things. So.
But of course, that's all hidden from the user. You can just do it in 2 lines of code. Wake up, send something, go back to sleep.
Yeah,
right?
Absolutely.
Yep.
So do you guys have any interface hardware outside of that then to kind of speed up that process and kind of like queue it up? So it's like wake up, talk to some intermediate device, and then and then don't have to talk directly to a router type of thing, or is it always going to be through a Wi-Fi gateway like that? Is that always going to be the main thing?
Yeah, so our model is generally, at the point where you're connecting to the internet, you're not that time sensitive. And right, so if it's, more often than not, it's actually the sequence is actually wake up, capture an event, and then connect to the internet and send the event up.
Okay.
Right. So we can wake up and start measuring things and running code. And I think we're somewhere around 50 milliseconds, which is longer than you would have for your average hardware. But considering that's bringing up an entire OS, starting a VM and then executing your interpreted code inside of a VM
really?
is pretty quick.
Yeah.
What do you guys run all that? It's not open, I'm guessing, but what OS do you guys use on there?
So it's a heavily modified version of ECOS.
Oh, okay. Yeah, I've used that before.
Right. Yep.
So, at this point,
it's basically imp cost at this point, right?
Yeah. And to the point where we actually refer to it as the imp OS because there's so much stuff in it that's so heavily customized.
Right.
Yeah. Well, that's good. I mean, that's what you do for custom getting good power and stuff like that.
Mm-hmm.
From the hardware side of things, as a user of this stuff, what hardware interfaces do you have on this imp module? Does it have just digital inputs? Does it have ADC inputs, I2C, SPI?
Yeah, so
how can I hook my stuff, my sensors up to your module?
I love this question because yes, all of it. No, so
well, of course.
we're very fortunate. The STM32 has really great peripheral options, and then on top of it, what we actually did was because we were limited by the number of sort of useful I/O pins that we could bring out. Because the first generation was actually in an SD card form factor, which limits you to six I/O pins in total. The second generation solder down module that went from 6 to 12, and the third generation IMP003 module goes from 12 to 23. So
are you still selling all of those different hardware platforms?
Yeah.
Or have you?
Yeah.
Right.
So
okay.
they're all intended for sort of different users. The SD card is phenomenal for prototyping. One of the great things about it is, basically then sort of the more expensive, from a hobbyist perspective, the more expensive Wi-Fi part can be removed from a project. So you just buy a breakout board, you stick it in, and, basically you think of it as sort of in the same way you would your Arduino and the shields, right? You can take the Arduino off and leave your shields all hooked up to whatever it was you had, and move that card around. This solder down, the second generation solder down module is great for customers who don't have a lot of RF experience. It's got an integrated antenna, things like that. It's all on board. You just plunk it down and give it power, and it's online. That's it. And then the third generation is intended for customers who have more RF experience. It's a lot smaller, a little bit lower cost, but with that cost down, you have to put down some external RF components. You have to provide your own antenna.
Sure.
So it's kind of a tiered architecture. For different customers.
So with the SD card, it's physically the size of an SD card, and you've got the Wi-Fi module built into that.
Yep.
Now, I was gobsmacked when I think the first company to do this was the iFi card, which you put into your camera. It saved images just like an SD card, but it, transmit. And everyone, I just went, wow, you can fit a Wi-Fi module into an SD card? How the hell are they doing that? Is it that hard these days? I assume it was hard back when they did it because they were the first to do it, but...
I mean, if you're wondering the size of the chip versus the size of the SD card, it's not hard.
Right. No, but you've got to have an antenna. You've got to have a Wi-Fi antenna in there. You've got to have the Wi-Fi antenna in there, and you've got to get the performance.
Our antenna takes up a third of the total area on the card.
Yep.
And so that's significant. And you're getting a processor plus a Wi-Fi module in there.
Yep.
The iFi I actually think the iFi might have been a little bit more challenging because it had to have, it also had onboard NAND storage. which is physically
it
large.
had to have a huge die on there.
Right.
Yeah, it had to have 8 gig or something worth of die.
Right.
So there,
we're lucky that we just have to put down our tiny little STM32.
Yeah.
Actually,
exactly.
the biggest issue with it is actually thickness. The
I was going
area
to say,
is not
what
a problem.
package do you use? Are you doing just bare die? Are you doing flip chip or what?
We use just CSPs. It's the off the shelf. I mean, one of the things is as well as a startup, you don't have access to, a lot of no chip manufacturer is going to make a custom package just for a startup, right?
Yeah.
So we had to buy things that we could get off the shelf that were already being used in high volumes. So we just used the CSPs and they're relatively thin. We did have to be very aggressive on our PCB thickness.
I was going to say, what are you using? 0.3 millimeter PCB?
It's even less than that. It's
okay.
0.24.
Yep.
Four
It's
layers.
0.24. Yep.
It is. It is.
They're incredibly flexible.
Stiff.
If you've never, for those who haven't actually played with a large. A large size, 0.3 millimeter or something PCB. They are ridiculously flexible.
What's your ruler?
They are almost flex boards.
My
ruler is 0.5 millimeters.
Okay, yeah, that's a good reference point for a lot of people, I'm sure. The PCB
or was
ruler.
it point? Yeah, I mean the standard one is 0.8, and most manufacturers will go down to 0.5, but anything under that gets a bit more special. They're almost down to the point where they're not a regular PCB. They're actually designed as the prepreg material which goes in multi-layer boards. So they're actually, rather than just like a stock thickness board, they're actually using just one internal layer of a multi-layer board for you. That's pretty much what they end up doing. But they are so flexible.
And the other big challenge on it was actually as well. It was we wanted white plastic instead of your traditional black or blue, or in case of iFi, an orange. And it turns out white plastic is a lot more transparent. And so the very first generation, the first couple runs, the white plastic was so thin you could actually see parts through it.
See, that would have been cool to me.
That's awesome.
Yeah.
I know.
Yeah,
that's awesome.
The problem is it also gets really brittle at those thicknesses.
Okay.
So we ended up having to thicken it up and find something that was a little more flexible. Right. Didn't become brittle. And yeah, I mean, there's challenges like that. And even we were looking at, we had to put our logo and FCC ID information on there and things like that. And we literally didn't have enough room, enough Z-stack to fit a sticker. Right. The sticker would have put us over thickness. Yeah. So we had to, laser etch everything on. And, that's another advantage of having white plastic is you can just laser etch the logo on it and it looks really nice.
Yeah.
Nice.
Which it is a fun little logo too. It's
So how do you make these SD cards? Are they like, do they come as two case halves and they're fused together? How do you assemble an SD card? I've never actually looked at the details.
Yeah, so it's there's some retaining clips and a little bit of adhesive, pressure sensitive adhesive inside of there to sort of hold things in place until basically until they go into an ultrasonic welding machine.
Right, so they do ultrasonic.
Yeah, and then it's just ultrasonic welding all around the edges, and that's actually a very important step because it's what gives the entire thing the rigidity, because the PCB is so thin and the center plastic is so thin that your structure actually comes from that outer ring of ultrasonically welded plastic.
That's pretty cool.
Got it. Huh. And who has to assemble this for you? An SD card manufacturer who specializes in that, or can some sort of assembly house do it for you?
So we work with a factory in China to build them, and so we brought
a factory in China. That narrows it down.
That's how it goes. They make.
There's not many of them there, so I think we know who you're talking about.
Yeah. So we work with a factory, and they have some experience doing other networking gear and things like that, and finished goods and plastics. So they hadn't the big thing there was they hadn't done laser etching before, so we had to buy a laser etching machine and store it in their factory.
All right.
So
that's cool. So can we go back to the actual the processor side of things? So we talked about there's 6. Because I think, like you said, I think for the hobbyists, for a lot of the people that are going to get started with this thing, you're going to start with the SD card. But how much do you find that people are actually using this as their main processor in a project, right? For like some kind of external hardware, and how many are using this as a peripheral off of another micro that might be on board, like a Arduino talking to this or something else talking to this? Is that even a necessity, or do you find most people doing just straight out of the processor here?
So I'm not sure what the breakdown is, but I would say the majority of our customers don't have a secondary microcontroller. They run the entire thing hosted within the imp itself. One of the great advantages of doing that is that because you can update everything from a web browser. You write new code, you push go, it downloads it, it's done, no matter where it is in the world.
That's pretty fun.
Actually, at Maker Faire, right after we launched, there were some issues with a couple of the device driver code, and I couldn't get my laptop onto Wi-Fi inside of the hull. So I went outside using a 3G connection and was pushing code updates over my cellular network to the other cellular network that all of them were connected. The AT&T hotspot they were all on.
Oh yeah,
and they were updating automatically during the middle of the show.
Yeah.
We've done stuff like that all the time. You can leave hardware on your desk and, you forget to take it home. Well, it's all right. You just sit there and you run it from, you bring it up in your web browser and you can debug it from anywhere, which is a really, really spectacular. Once you forget that that's not how most microcontrollers are, it's hard to go back.
Well, yeah. The only thing that stinks about that is sometimes I've done that with like one or two remote devices before. The only thing that stinks about that is it's like, oh crap, now I need a webcam because I put that LED on there as a visual.
Yeah.
So that's your next product is the troubleshooting webcam. That's what you should do next.
Why can't I find like details on your website about like the SD card and stuff like a data sheet for these things? I'm just bumming around on here, and it's not even in the product gallery. All you've got is the Budweiser thing and the Locatron and the Haiku and the.
So if you scroll all the way to the bottom,
yep,
you'll find a link to the Dev Center.
Dev Center, right?
So this
Dev
is
kits.
this is the unfortunate reality of the majority of people who come to electricimp.com are just sort of checking us out and non-technical. And so some of the technical details all hidden in there. Yeah. So if you find our electricimp.com, go to the Dev Center, and then you can go into hardware. Okay. You can find data sheets for any of the three products.
Got it. Yep. Found it now. Oh yeah. And you sell the modules through Adafruit and DigiKey and Jameco and SparkFun.
Yep.
Right. Awesome.
So open the box, get it up, get an LED blinking to it. 2 lines of code, 1 line of code. What are we talking here?
Yeah, I think you just need 1.
Wow.
Depends how fast you want your LED to blink, but yeah. So you can just configure a pin as a PWM is a single command line, single line of code. Yep. I think the minimum frequency on PWM is every 60 seconds. So as long as you're cool with it blinking for 1 second at a time. Yeah, 1 line of code.
Well, that's what everyone expects these days. I mean, with the Arduino generation, I guess you could call them, they expect that sort of simplicity.
Yeah.
So what about the other end of the spectrum then? So have you found yourself limited in terms of complexity? Is that mostly just in pin count or response time or anything like that?
So pin count is one of the biggest challenges with 6 pins is rarely enough if it's any kind of real complex device. It's great. We do a lot of things, especially with like I2C, right, where it's like I can plunk down 12 sensors and only use 2 pins. So that's a great solution for low pin count devices, but the cost adds up pretty quickly. 12 pins most of the time is enough. We also add you can get an I2C based IO expander. They can take a lot of the resources. In terms of the code, I mean, we have customers who are running 4,000 plus lines of code. That's all being written in an interpreted language. So, your typical code density versus what you'd have in C, 4,000 lines of code is really probably like
50,000 lines.
Yeah.
Is there is there a way to go lower level if you really want to, if you're a real diehard?
So there isn't.
Or do you guys go, no way, Jose?
The main reason being, this is, again, it's Hugo, our CEO, and myself both have come from Apple, and it's kind of part of the ensuring the software engineer has the right experience. And so as soon as you start exposing lower level APIs, allowing them, the first thing you're going to want is to allocate memory, right?
Right. Yeah.
Right.
Oh, yeah. And then you're screwed. Right.
Right.
Yeah.
And then it's game over. Right now you can brick your device. Now you wipe out your operating system. Right. As soon as you do that, all bets are off. So our goal is, again, that you should never be able to push down an update to the imp that you can't recover just by changing your code and hitting go.
Got it.
So it's
fair enough.
Again, I'm a hardware engineer. There are times where it drives me nuts, and actually one of the big things has actually been a learning experience for us about what are the shortcomings. What does that actually imply? And so we have native SPI peripherals. So for something like that you typically bit bang, like a infrared remote to control your TV. On your Arduino would typically just be pin states and delays, and that would be fine. Well, we don't want to block the processor for that long, and because you're running an interpreted language, timing is a little more challenging.
Yeah.
So we use the SPI peripheral for it. And so we build the entire packet in SPI and then let it do the work of just shifting out bits at the right frequency.
Nice.
So wait, so you're saying if you were going to do an IR remote, would you be writing to another expander type of thing, or no?
No. So I mean, it could be as simple as hooking up a infrared LED to a pin on the imp, and then to a SPI data output pin, the MOSI pin, and then just some software to basically where the data would be formatted into the what you want the IR sequence to look like.
Oh, okay. Mm-hmm. Okay. So So you're writing a bit pattern effectively to like a queue inside of like a queued SPI module type of thing.
Right.
And then it just clocks it all out without. Yeah, because you need that overhead. You need to switch back to your threads or whatever so that you can go talk to the Wi-Fi and everything else and do your updates and power checks.
That's actually like the far and away the biggest challenge for new developers who come from microcontroller land is the first thing they want to do is a WoW 1.
Yeah.
Right.
And it just doesn't work in the internet age, right?
Let's talk mutexes. Blah blah.
Yeah. So it's a big challenge to get people transitioned over from that to an event-driven programming. But there's a lot of like just spectacular things about it that you never want to go back. And some of like the other really cool sort of really bonus side effects is, because the entire operating system is event-driven, we can actually do at an operating system dynamic power management, where when there's nothing to do, we just idle down the processor and peripherals to a lower clock rate to save power. And it's completely transparent to the application because nothing's happening during that time. And then as soon as an event, a scheduled event, is ready, all of that stuff comes back up and it starts executing.
Huh. So really what I'm hearing is that the trade-off for people that are developing with this thing is you give up something on the low level knowledge of what's going on, but what you get is like built-in optimization for power effectively, because that's really like the thing that is annoying for like I hear embedded people talking about that. Oh well, I got it working in 2 weeks and then I spent 3 months fixing the power scheme.
Yeah, so I mean, power is a huge part of it. There's a lot of other just one of the biggest things is just that networking is fundamentally asynchronous, right?
Yeah.
In microcontroller land, there's no real notion of an asynchronous event. Typically even within an Arduino, rather than setting up ISRs for a button, people just pull the buttons.
Yeah.
It's just a lot easier. And the problem is if you need to be doing anything else, it's just a terrible form factor. And it means that now all of a sudden, when you want to do some low power, it's really hard to tell, well, do I actually need to be reading the button or am I just sitting here spinning?
You have to change your entire code architecture of how you wrote the thing.
Yeah. So, it also really limits the number of things you can do in that loop, right? If you have multiple devices that you're trying to service, just sitting there and looping through all of them and blocking on any one of them really decreases your performance. One of the reference designs we have is called Nora, and it's got a accelerometer, a temperature, light level, barometric pressure, humidity, all these different sensors on it. And they all take it all runs off of 2 AA's. And so you don't really want to be.
You just ran a Kickstarter, right? Wasn't there like 14 different Kickstarters that did just that?
Yeah. So there's actually even a quirky product called Spotter that's quite similar. But sort of the idea is one of the great things is we can actually come up and I know that the humidity sensor takes the longest to read. And so I can actually start events that says, okay, I have to prime the humidity sensor because it takes like 150 milliseconds to initiate. So I start that, and then as soon as that's done, I start reading all my other sensors, but each one of them has some delay. And so I can just schedule, basically, I can start all of them, and when I start them, I say, okay, now pick up the data in 150 milliseconds, or pick up the data in 80 milliseconds, and everything is scheduled out. And then all of a sudden, you get to the end, and all of your data is collected in the basically in the guaranteed minimum time, because the humidity sensor will be the last one to be connected, and rather than blocking for 150 milliseconds, then 100 milliseconds, then 100 milliseconds for each sensor, we're able to do them in a parallel approach, which would be very hard with a traditional microcontroller.
Definitely. Wow, that's cool. That's really cool. What about let's talk power. I mean, so what are we talking here in terms of sleep power, deep sleep, active power, that stuff?
So I love the power story here. It's actually something we spend a ton of time with because one of the greatest advantages is we think we bring to the table is the ability to do battery powered devices, which very few internet connected devices are actually battery powered. And so we can go our deep sleep, which is basically everything off, keeps an RTC, and it has one wake pin, and that gets you down to between 4 and 6 microamps, depending on which imp you're on.
Yep. Is there any other way to wake it up apart from the wake pin? Can it wake on a real-time clock event?
Yeah, so it wakes either on a timer or on a pin interrupt.
Yep. And of course, that's all built into the STM32 processor,
yes.
right?
So when you go to sleep, you can say, wake me up in a day, wake me up in 15 minutes. So if you're doing something like that Nora reference design where you just want to wake up, read all your sensors, send them to the internet, go back to sleep for 15 minutes. So you're just sort of doing a logging application. It's super simple.
Got it.
And you also have the option. So like on that design, we also have like the accelerometer. So if you want to wake, if you're disturbed, right, that's really easy to do. It's like you set up the accelerometer for an interrupt, and it's connected to the wake pin, and voila, you wake up and send the results immediately.
Got it.
So so deep sleep, sort of everything down, gets you down to 4 to 6 microamps. And the interesting thing there, we actually play a fun game, which is the minimum voltage for Wi-Fi is 2.5 volts, but the minimum voltage for the processor is only 1.8, which means with Wi-Fi off, we can run directly from 2 AA batteries.
Nice. Yep. Right down to what minimum voltage on the battery, because a battery will exhaust its capacity at 0.8 volts, an alkaline will.
Right. So we typically run them down to about 2 volts. Basically, anything as soon as you really, even then, getting to about 2.2, they don't have enough they don't have enough juice left in them to bring Wi-Fi up. Yep. So running a processor, if you can't bring the Wi-Fi up, isn't really that meaningful.
That was going to be my next question. What is your minimum battery capacity, your sort of like your highest impedance you can use? Can you use AAA batteries? Can you use CR2050s? I assume they'd have too high an impedance to fire up the Wi-Fi module.
Yeah, so well, and additionally, we actually have to boost the voltage up once we get down to those ranges.
Okay.
So that actually, and that you pay for the current in that.
You have to boost the voltage for the Wi-Fi.
Right. So we use a boost converter that has a pass through. So when the imp wants to turn Wi-Fi on, it sets the enable pin high. So it goes from battery voltage up to, we typically set to 2.7 to give ourselves a little headroom.
Yep.
And then we can operate at 2.7 and turn on Wi-Fi and be happy. The biggest issue is the Wi-Fi chip, when it powers on, has to do a calibration cycle where it basically sits there and sends packets at maximum power without the antenna connected.
Poo.
Yeah, and so those transients those transients get up to 250 milliamps.
Ooh. How much of an impulse?
Do you need some local how much local decoupling do you need
so
for that?
We typically on the on most things just 1 microfarads externally. We also have onboard inside the module there's capacitance. And so with most power supplies, just sort of the standard decoupling is sufficient. Running off of 2 AA batteries, we put an electrolytic in parallel with the batteries. And that what we found was we did like battery life testing with no electrolytic with a 220 and 470 and a 1000.
There'd be a big difference.
Yeah. And for alkaline batteries makes a tremendous difference. One of the things we're quite fond of course, the solution to any engineering problem is to spend more money.
That's correct. Yes.
Is the Energizer makes the in the US they sell the lithium iron sulfide.
Oh, okay.
And those batteries are awesome.
Oh, those are the LiFeO, the LiFeO 3s, right? Yeah.
Yeah.
Because they've got stupidly low impedance and massive, over
they
their
basically
full operational.
They hold their voltage across the entire thing, and then when they're done, they're just done.
Yeah, they snap
right.
off.
It just falls off. So actually, on our website, if anyone ever wants to take a look, there's a great graph under reference designs for the NORA reference design, because I tested with 3 different battery chemistries with just Duracell alkaline batteries, the Eneloop nickel metal hydrides, and the Energizer lithium batteries. And it's as an engineer, it's a great little graph of how they behave under sort of similar circumstances. And we have these high load transients, and that's actually where we end up burning a lot of our power. Because once you're actually online, it's not substantial.
Oh yeah, totally.
Yeah.
Yep.
So what is so you said 250 milliamps, but really we should speak in joules almost, right? I mean, like, because it's about the impulse as well. Like, what is? Yeah. How long is that impulse?
Very short. So and I mean, I don't remember what it is off the top of my head. We measure it,
microseconds, nanoseconds?
Tens to hundreds of microseconds.
Okay. Yeah, that's okay.
Yep.
So it's in the range that you can pretty easily decouple it.
So that's like microjoules, right? Is that right?
Yeah, somewhere in there. So we measure what's usually more important. So we recommend electrolytics for battery powered applications. It does significantly increase battery life, especially in combination with alkaline batteries. With the nickel metal hydrides or with the lithium iron. The Energizer lithium batteries, it's not as big of a difference. The output impedance is so much lower on those that you're not, and it's more or less constant across the entire battery life. It's not as substantial.
So, how long will a typical product last on 2 AA alkalines? For example, I don't know, spitting out, a thing per minute or something like that.
So
a data packet per minute or even per hour or something like that.
So basically we measure things, and for us the wakes are typically so much higher than the sleep current. We optimize the entire. You have to consider that in the entire product, that you basically want your sleep current to get to 0. And if you do that right, then it's just the power to wake up. Alkaline batteries, we can get maybe 60,000 wakes off of a single pair. If you're
60,000. Okay, let me do some math.
So if you're connecting every minute, You get what, 1,000? I don't know. Yeah, it's a bunch.
I think it's right.
So you can.
I think it's 41 days or something.
Yeah, 41 days.
41 days
at every minute. Typically
at every minute, right?
You know, we'd be talking more like every 10 minutes or every 15 minutes for that kind of data logging.
Okay, so you could run for quite a few months.
Yeah, so I mean, like Nora at 15 minutes, you know, I think we did 15 minutes every, and then waking up and just collecting data every minute. Yep. So it's uploading 15 minutes of data every 15 minutes.
Right.
We were getting, 1.5 years on standard alkalines.
Wow.
So that's very impressive.
Okay, I'm impressed. Yeah. That's almost game changing.
Yeah, so for Wi-Fi. That's the thing that I think we have to call out here too, right? We have to make that distinction. This is Wi-Fi versus Bluetooth versus
Wi-Fi.
ANT versus...
It's not Bluetooth LE. This is like Wi-Fi. It connects to your standard router, so you can just shove stuff in your house. And
how do you guys classify like distance to router, stuff like that? I mean, like what router power, or does that not really... Is it more of just a blind transmit?
No, so because Wi-Fi is sort of fundamentally TDMA, that everybody's talking at a different time. There's actually
multiplexing. Is that sorry, I don't know.
Time division multiple access.
Okay. Yeah, so you're, whereas with a cell phone, you actually have an incentive with your standard LTE, you have an incentive to lower your output power so that the base stations can sort of just barely hear you. In Wi-Fi, it's actually sort of the opposite, which is you want everybody to hear you when you're talking. So you actually always want to transmit at your maximum power.
Okay.
It's
But are you able to scale it back? Do you have to? If you know that your widget is only going to be, 1 meter away from your Wi-Fi thing.
So you possibly could, but again, the network as a whole, if you are only concerned with your network performance, your network is still better off having every device transmit at a maximum power. Because what it means is that if there's somebody, if you're right next to the access point and there's somebody who's far away, and so you say, oh, well, I'll back off my power, and so the access point can just barely hear me. The person that's way out there can't hear you, so you both start talking at the same time, and the access point's like, whoa, guys, you're talking at the same time, I can't hear you, right? But the guy out there doesn't know that that anybody's talking, right? And so he's like, hey, what gives? I thought I had the channel. So it's a better system when your network performance goes up when everybody can hear everyone else, and the best way to do that is to have everyone talk at maximum volume.
The first person to write a dramatic play based on Wi-Fi devices talking to one another wins the biggest award in the world. But I couldn't hear you.
Yeah. I mean, it's one of those things that as an engineer just seems wrong and seems like it should be optimized. But again, for most of our stuff, the actual radiated power, the power going into the antenna isn't the thing that really uses the most juice. A lot of it is just keeping the receivers on and PLLs up and all that jazz. Is a lot of it's just system overhead. So reducing your output power isn't a way that's going to save you a ton of battery life.
Got it. Do you have issues with like the SD card one, for example, or even the module? Right, people put a big whacking ground plane.
Oh yeah,
under it. How does that limit the performance? And do you have to go, look, guys, don't put a bloody ground plane under it? What's the story?
My team is responsible. Sort of our goal is to help customers have a positive first experience. And so we've developed a lot of documents. We've got a document that's, building successful devices that basically says, hey, don't put a ground plane under your antenna. Right.
Now we're going to talk some RF theory.
The bigger one is actually, that's actually rarely the problem. Usually the problem we have is people putting no ground plane anywhere whatsoever. Right. Yes. Which you can do, or they'll have a switching power supply and the inductors, placed next to the amp and the chip is placed next to the USB jack, right? And it's like, that's not how that works.
I looped the trace all over the board to try and make it better.
Yeah.
It's a longer
well, I couldn't get a big enough inductor, so I added some trace to it. So yeah, that's actually so the no ground pour is way more common for us. That you just see sort of auto routed. All the grounds are connected. Check.
T-shirt sales end next week, folks. Never trust the auto router.
Yeah, it will be wrong 100% of the time.
Oh man.
Oh, that's hilarious.
Yeah, that's one of my favorites.
So we didn't actually cover the other. So we mentioned deep sleep. What are the other sleep modes?
Oh yeah, so on with Wi-Fi off gets you right. And again, all of these things, because we do dynamic power management, a lot of it depends on what you're actually doing, right? You know, if you're sitting there clocking out SPI on a heavily capacitively loaded bus, your power numbers are going to change.
Yes.
So, you know, or you're trying to use an imp to compute Bitcoin. I don't know. So I'm just going to give ballpark numbers. So basically, STM32 running, not a whole lot going on, gets you into sort of the 1 to 2 milliamp range with Wi-Fi on, but with Wi-Fi power save, puts you up in the 5 or 6 milliamp range. And then sort of just stock out of the box, you don't do anything, it comes up at 100 milliamps. That gives you sort of the best Wi-Fi performance, the lowest latency. As you go to Wi-Fi power save modes, you have latency for incoming packets. We sort of come up with in the most performant mode, and then allow your code to bring it down from there and say, no, I want lower performance. I'm running on batteries.
Okay.
Got it.
Okay. So that's the on with Wi-Fi off. There's other ones as well.
Sorry. So on with Wi-Fi off is 1 or 2. On with Wi-Fi on in power save is 5 or 6, and then all out everything on is 100 milliamps.
Oh, okay.
Right.
Okay. So, well, and you wouldn't do that for long though, right? I mean, these are short cycles still. It's wake up, do your thing, go back to sleep.
Yeah. So, I mean, typically, I've forgotten the exact number, so we can do a full wake up, connect, send data, and get back to sleep very quickly. And so even though our power level is relatively high in that, it means that the actual joules used is still relatively low. And there's actually, one of the things with power saving is it takes time to get into power saving modes and things like that. So It's actually, even in Wi-Fi to drop down to the next power saving mode, unless you're online for 300 milliseconds or more, there's no incentive because it takes up to 300 milliseconds to take effect.
Huh. Okay. Well, that's interesting. And that's probably all the data sheet you said too, right? I mean, like
most of that's in there. We also the Dev Center has a lot more resources, things that are not strictly a data sheet. You really want everything in there to be absolutely verifiable and not sort of rule of thumb, right? So that when somebody says, well, I configured every single peripheral and I'm clocking out at 30 megahertz and I'm not hitting the power numbers you quote in your data sheet. There's a little more nuance. So
and I'd
a
like
lot
a
of it's
refund,
up in
please.
our developer center. We try and put a lot of information in there, and it's growing every day. So
that's good. What about this blink? The blink thing?
up.
Yeah, what's that? Tell us about that. That's interesting.
So blink up is our configuration method. So, sort of the fundamental problem almost every single Wi-Fi device has is how do you get a network name and password into the device? And if you've ever bought a USB, a Wi-Fi printer, that process can be insanely painful where you're sitting there using an up arrow and an enter button to try and sort of type something in, right?
Why did I use an ampersand? Why did I use an ampersand?
Yeah. Scroll.
Yeah.
So, and the problem is on a printer, putting buttons and a display is totally reasonable. If you're trying to sell an internet connected device for $50, you don't have room. You don't have room for buttons. You don't have room for a display. You certainly don't have the budget for those items.
Right.
So having a way of getting that information into the device is extremely important. So we use the idea is that most adopters of internet connected devices also have smartphones. And so we use the smartphone to set up the device. We thought the sort of the traditional process of Well, it looks like an access point. You join the access point, you load a web page, you type the information into the web page. It then reconfigures. You go back into settings, you go back to your normal Wi-Fi. It's like, that's just a pain. It's terrible for users. It's like, hey, set up in less than 5 minutes. It's like 5 minutes is way too long to be setting up a device. So our
PhD not included.
Yeah, the process we use is our technology called BlinkUp, where basically it flashes optically. So every if you buy the card, it's literally integrated into the card. If you're buying a solder down module, you add a photo transistor externally.
Oh, okay. So you've got to add it. So you don't have one inside your module that has a little peephole.
Right. One of the biggest complaints with the card was that they had to customers had to expose the card so they could get light in. One of the great things with the solder down version is, well, you can put the module anywhere you want and just expose the photo transistor.
Right.
So you add a photo transistor, and basically photo transistor just changes a voltage when it sees light or dark. And so it's, using an iPhone, it's as simple as the refresh rate of the screen is extremely reliable, always at 60 hertz. And so literally just, if it sees black, it counts as a 0. If it sees white, it counts as a 1.
Yep.
And we have some algorithms on the device. So it basically samples it as it uses an ADC and samples the incoming signal, looks for edges, basically transitioning between black and white. And you can send data that way. So it has a little synchronization, and we pack all that data into a format that's that contains the Wi-Fi SSID, the password, to get it on the Wi-Fi network, as well as the user's credentials, so that we know who that device belongs to, and it gets added to the right account. So that's actually part of sort of the ownership process as you go and you blink up your device. And it's a really awesome thing to use. Once the first time you see it, you're like, oh, cool.
Yeah.
Well, it's technology straight out of the 1970s.
Yeah,
What if instead you had the two electrodes where you touch those as well, and that does the programming? Do you remember those devices as well? The ones you actually had to physically touch them together. That could be next.
Mm-hmm.
Yeah.
Yeah, this was like 1970s. All your light guns and your light pens and everything interfaced with your CRT screen, which had a little dot in the corner, and you could send data. And you guys have got a bloody patent pending on this thing. Obviously, something deep, very specific and niche.
Yeah. So I mean, the patent is really geared more towards using it for Wi-Fi setup.
Right.
We're not foolish. Like, we know we didn't invent, hey, I can send data with flashing lights, right? There's the entire fiber optics industry might have something to say about that.
That's right. Yeah. Late 90s called.
But yeah. So no. So it's really about using that as a way of configuring just Wi-Fi credentials. So
that's great.
Right.
That's really great. Yeah, and we talked to Adam. Dave wasn't there for this, but Adam Wolf from Wayne and Lane, they talked about doing some similar stuff on their device when they were trying to program I think it was just an AVR or something, but using a CRT type screen. So that's an older episode. I don't remember which one it was, but people may remember or can go listen to that one as well. Yep. What about going forwards? Are you guys going to push into other technologies, you think? I mean, Wi-Fi is cool. Bluetooth. I mean, are you going to actually do that, or stick with what you know?
I sure hope so. No, I mean, yeah, that's sort of the idea, right? Again, we're if we're positioning ourselves as a connectivity platform, having other kinds of connectivity seems to only make sense. Bluetooth's a little harder because sort of one of the core tenets of our platform is the internet portion of it. Right. It's what gets your devices online. And right now, we see lots of Bluetooth devices and a lot of them are being positioned as internet connected devices, but they're really not. They're phone connected devices.
You need a PC. Yeah, you've got to have something in between. You can't just connect a Bluetooth something gadget to the internet. It doesn't work.
So, Wi-Fi was a great first choice for us. The obvious next step is cellular.
Well, there's only two choices, isn't there? There's Wi-Fi or cellular. That's how we get our our internet points of presence in your home, your office, your out in the public.
Ubiquity, right? Yeah,
right.
Yeah. They're the only, as far as I know. Please correct me if I'm wrong. There is no other option.
No, that's pretty much it. So but the idea is that because we have this, we've abstracted the connectivity layer of it. A single customer could have devices that are either cellular or Wi-Fi. And they're not, one of the biggest challenges has been traditionally, it's like, well, the connectivity was the hard part of the connected product. And so for them, really now it's about creating the customer interface and a slick app and things like that. And getting that kind of engagement is the challenging portion. And which means, if we roll out a cellular solution, that means that they can transition from Wi-Fi to cellular and have the exact same experience, and not be hiring, RF engineers and things like that to go through all the challenges. The biggest issue with cellular is just the approvals process. Wi-Fi is great; it's unlicensed band. You pass FCC, that's it. Ship it. Cellular is much, much more complicated. The carriers are,
I hear AT&T is very pleasant.
Yeah. So it's a hurdle, but again, it's this sort of thing where if we can solve that challenge for a lot of our customers, that gives us a really great advantage of being able to sort of amortize this large fixed development cost across many customers and make something that wouldn't, you just can't sell something at a reasonable price that's cellular these days. In relatively low volume, because the approvals. AT&T released a white paper saying they've been really pushing to get development costs down, and they've pushed it down to $40,000 in 6 months.
Whoa! Right.
Like what kind of products can sit around for 6 months and spend $40,000 before you ship a single one?
No. And to roll your own sort of unique solution there, you've got to be like an Amazon, like with the Amazon Kindle. They had their own 3G solution or so, or they partnered up with some, but
WhisperNet.
But you didn't know any of that. It just worked. It just magically worked. And but hey, they're Amazon, right?
A little more money there.
How big is Imp now? How many employees you got?
I think we're coming up on. We're high 30s, might have hit 40.
Nice.
High 30s
okay.
still.
Right.
Very cool.
And you guys were a startup, and you got funded by a couple of
so we took the traditional Silicon Valley, go get VC funding.
Right.
We've recently closed a Series B round, and which is great to feel like we have. It's a good validation of the platform and gives us a really nice runway to focus on bringing in, we're coming up on 500,000, but I come from Apple, right? 500,000 is
pilot build
is like not even launch day, right? Like
I know exactly.
So we really want to be pushing towards the the millions of devices and into tens of millions, and with the kind of fundraising we've done, and one of the other big things is partnering with some hardware manufacturers, like we did with Murata. That frees up a lot of capital for us, that they're bearing the capital expense of building product and holding inventory, that gives us a lot more runway.
So they will hold inventory as well, not just make this.
So we are actually it's a full-on partnership where basically they are responsible for the entire hardware solution, and we are just responsible for the software.
That's cool.
Right.
And that's cool. So, that's the chip-based one, right? The 26-pin module you mentioned. That.
Yeah. So it looks like a chip. It's really is chips and discretes inside of it, but it's all poured into a pretty molded plastic, and so you get a very like chip-like feel, but it's got an integrated shield and everything else. They have some really excellent technology.
We'll definitely link that in. That sounded really cool.
They do some really, really great stuff. They're spectacular engineers over there.
I would have thought it would have been easier. The venture, it makes it sound so easy. Just go out and get the venture capital funding. I think it would have been a tad easier that Hugo, your CEO and founder, was the former head hardware guy at Apple. I mean, head hardware design team or something, right? That carries a lot of weight, I would presume, with the venture capital.
Yeah.
Nest.
He also spent some time at Nest and did their first hardware design. So he's got the Nest serial number 1 on his wall at home.
That's awesome.
Right. Okay, there you go.
So it does make it easier, but it's still it's a hard road. And
with hardware, yeah.
Yeah. Well, and the big thing is, it's really hard to explain to a venture capitalist why we should be building a platform instead of a product.
Right. But I thought they were all about platform
I would have thought that
these
too.
days.
Yeah.
Platform as a service.
They want to capture
all
all of this stuff. Everybody comes to one thing, right? That's the ultimate.
Who the hell wants to make hardware anymore?
So it's really popular in the software world, but sort of, there aren't a lot of companies doing hardware as a platform, right? And hardware, and really hardware as a service, right? That the whole idea of the Electrocam platform is that you don't have to worry about the hardware, right? It's just sort of like, whatever, somebody designed it, it works, it's online, I can send code to it, right? In the same way that you don't have to worry about what kind of hardware your Amazon server is running on. It's like, whatever, it runs Linux and does these things, right? It's just like, so, I think that getting venture capitalists to the point of understanding that was a really big challenge. And they're sometimes known for wanting to make a quick buck, and that's yeah, right.
I am shocked. I don't believe it.
Shocked. So that's the other problem with the platform, right? Is it takes a long time to build. It's not just sort of get one product on the market, ship it, and you're done. What's next? It's supporting the platform, building the platform.
Yeah, right.
All right. So
switching coding languages the day before you launch.
Rewriting everything you've ever written. In the 1 week before Maker Faire.
That's fun.
So yeah, no.
See what your big launch was at Maker Faire?
So that was our first. We sort of did a press campaign before that, but that was the first public demonstration of our technology. So
see, that's interesting. Usually it'd be CES or some other, wanky businessy.
Yeah. So
thing.
This is actually one of the things I love about Electrocamp and something that has been like such a blessing as an engineer and in terms of workplace satisfaction is we're still really involved with the maker community and the developer community. We all kind of came up through there. I've been playing with all of the different Arduinos, and we have a lot of people on board who've, been through that. And, a couple people have done their own Kickstarters and unsuccessful Kickstarters, but, that's kind of, it's been a really great community for us. And so Maker Faire was a great opportunity to get feedback from those users.
Because they're the ones who will give you feedback.
Well, and they get it, right? Like they
know the hard parts.
Yeah, totally.
Well,
and they've been there trying to parse XML on an 8-bit microcontroller. Right. Which your average, most of our big customers, they haven't been through that. Or they've been through it at a very high level. They've devoted, engineer hours and in some cases engineer years to trying to get a connected product online and failing. And so, it's a lot harder to sort of convince them and get them to give you feedback and things like that. Whereas the maker community is really open and receptive. We've been through, the hardware stayed the same, but even the platform has pretty radically changed. We started with sort of a simpler software solution where you could only write code that ran on the device. And then it just sort of had an input port, an HTTP input port, an output port. It had this, goofy sort of visual programming thing where you could connect one device to another and wire them all up. And, that was great for some things, but it just didn't scale to larger deployments. And as soon as people started getting to, even 5 or 10, they said, this isn't going to work for me. And so we've rewritten large portions of the platform because of that feedback we've gotten from those early customers.
That's awesome.
Nice.
Well, I think we're going to see a lot more of these. I don't know.
I sure hope so.
Yeah, I'm embarrassed to say I haven't tried one yet, but I think I have to now. I was mentioning to Dave before as well that so we're doing Hackaday Prize stuff together. I think we'll probably see some stuff in there some Hackaday prize.
I'd
entries.
be surprised if you didn't. We might even try and help seed some ideas and things like that. We've got a lot of reference designs online that are all free to use, so people can start with something that is working and everything else. That's part of our commitment to helping people have a successful first experience.
Thank you.
So I mean, we've had
I'm screwed otherwise.
We've had several customers go to mass production with their first spin of the PCB.
Nice.
I want to swear at you right now.
For something with Wi-Fi on it is pretty awesome.
Yeah, that's see, that's engineering cred right there. I think more than any money or any devices. Okay, yeah, but one spin of a PCB, that's pretty killer.
Yeah.
One last quick question: who do you see as your main competition in this area?
It's kind of hard to say. I mean, sort of the most obvious one is the Spark Core. They have a kind of different model from us. They're tending, we have sort of our open source policy is we're willing to open source all the stuff you need to use our platform. So we post everything, literally we tried to public domain all of our reference designs, and our lawyer said you can't do that.
Oh, boo.
Well, no, literally you can't, there's no law that allows you to make something public domain. The only thing you can do is apply the most permissive license you can possibly find.
Wait, so your lawyer turned you and said...
yeah, but that's lawyer talk. No, but that's lawyer talk. You actually can. Yeah. You can do it. It's just in their world it does not exist, but in the real world
So we found, I think it's the X11 license, which basically says, take this thing, do whatever the heck you want with it, don't tell us if it breaks.
Right.
Don't come crying to us.
I haven't heard of that one. The X11.
Yeah, it's X11. It's X11 and something else. I've forgotten. But yeah, so we like to open source all of our stuff that's required to use the platform. We have a big GitHub repo that has all kinds of device drivers. So if you want to hook up an accelerometer to an imp, all of that stuff to get a lot of squirrel code out there. But then the platform itself is that's kind of what we consider our proprietary IP. In the same way that Amazon doesn't tell you exactly how they run their servers, they let you run whatever you want on their servers. Whereas Spark is a much more open system. That in theory you'll be able to run your own servers and things like that. We think that that's not best for manufacturers, right? We spend a lot of time and a lot of energy getting our servers up and running and maintaining them, diagnosing problems, having the tools to be able to diagnose those problems. And then we can spread that cost across all of our customers. So they're kind of the most obvious. They're also, they also came out of the maker community. They did, a crowdfunding campaign, and
they were Hackcelerator, weren't they? I think they were out in
Shenzhen, I think that's right. They still have a different model than us. They're, I don't think they do low power as well as we do, but, they have gotten, they have made it, and quite frankly, I just like seeing more devices online and connected to the internet. I think our platform is good enough that as the entire number, as the number of devices grows, a big enough percentage of them will be using Electric Imp that really we profit regardless of who is putting the modules into a specific connected devices. It's about building a network and community, and this expectation that your devices should be smarter and should talk to each other and to you.
And me and Dave have to figure out how to do that. Crap. Damn it.
Well, no, first of all, we have to figure out a reason to do it.
No, there's no...
you don't just do it for the sake of it. I'm sorry.
Well, I think that's what you play around to start with.
That's what bugs me with the Internet of Things. People do it because they can, regardless of... Yeah.
Yeah, so, I mean, just to speak to that, one of the things that I like, because, and some of this is... when you work at a hammer factory, everything looks like a nail. But, one of the fun things I did was I took I recently bought a house, and it's the first time I've ever owned a garage door. So the concept of closing a garage door when you walk out of it is somewhat foreign to me. So I just took our Nora reference design that has an accelerometer on it and foam taped it to the inside of my garage door, and hooked it up to Twilio, which is a text messaging, an online text messaging service you can just interface to directly from the Imp platform. and had it send me a text message if my garage door was open for more than 5 minutes. Right?
Why?
Which was, and it was like, all right, to get 5 minutes from the house and send me a text. You forgot to shut the door. All right, loop back and go back and close the door. And it was something that, I was able to do in a couple hours, and it saved me leaving the door open all day and actually once all night. Nice. So, for me, that was worthwhile. And it wasn't something I could do it wasn't something I did just because I could. It was something that was a real problem for me.
Right. Right.
And that I was able to.
I would have said, yeah, actually just look back and check to see if shut the door.
Yeah, I guess I'm inherently lazy. Dave.
I'm so old school, yeah.
You can't just look at a garage door and tell if it's up or down.
It's like
how dare I?
It's like a Schrodinger cat kind of
thing. I need a 16-bit accelerometer to tell me what position it's in.
Oh, goodness. All right, Brandon. Well, thank you very much for joining us. It's been awesome.
Thanks for coming in, man.
Thanks for having me, guys. It was awesome.
People could find you social media anywhere like that. Can they bug you with that kind of stuff, or?
I generally run pretty dark, but the @ElectricImp Twitter handler usually makes its way to me if it's
hardware based
directed at me, or I also sort of feed those. You can also find ElectricImp on Facebook and all the usual places, and of course, our website electricimp.com. So,
and you can also find Brandon's garage door online before he is.
Yeah, if you can figure out the URL, you can know every time I come home.
Oh, that's funny. All right, well, thanks again, Brandon. It was great talking to you.
Thanks, mate.
Thanks a lot, guys.
See ya.
Brandon has just arrived home. Garage door is open. Garage door is still open.